Next here, equally likely events. The events are equally likely if each of them has the same chance of occurrence. In other words, equally likely events are such that none of them is greater chance of occurrence than the other. This condition usually applies to fair games of the chance, such as coin, dice, and cards here. For example, here throwing a fair die, then what is the sample space? 1, 2, 3, 4, 5, 6. Event A, we took here getting a 3. Event B here took here getting a 5. What is the probability of A? That is the 1 by 6. Getting a 3 is only 1, 3, and getting a 5 is also only one outcome. That is 1 by 6. Both have the same chance, 1 by 6, 1 by 6. But then so A and B are called here equally likely. Both are different event, but probability are getting the same chance. Then it is called as the equally likely events. Next is the independent events. The two events are said to be independent if the occurrence of one does not influence or change the probability of the other. Each event happens on its own. Okay, the probability of one event does not influence the change of the probability of the other one. It is called as the independent. For example, here when we tossing the two coins, the event A is here, the first coin shows the head, and event B here, the second coin shows the tail. These two events are independent because the result of the first coin does not affect the result of the second coin. If the result of the first event does not affecting on the result of the second event, means that are called as the independent events. Dependent events, that is the opposite of independent. The two events are said to be dependent if the occurrence of one event affects or changes the probability of the other. In such a case, the events are not independent because of the result of the first influences the result of the next. Here the first result is change or effect on the second, then it is called as the dependent event. Example here, drawing the two cards without replacement. Without replacement, dependent events will always come as the without replacement only. Event A, drawing ace on the first card, and event B, drawing ace on the second draw. So here, how many possibilities we have for drawing the first card here? We have totally 52 cards. The ace in the 52 deck means there is the 4. That will come 4 by 52. Without replacement, again the event B is also drawing ace on the second draw, means it will 1 we already drawn, that then it will come as the 3 by 52 because 1 already we drawn, so it will come 3 by 52. That is called as the this effect. The event B is effects on the, and the event A is effects on event B. So it is called as the dependent events. So next is the operation with the events. Since the events are the subset of the sample space, the operations, the set theory, such a union, intersection, complement, and difference can be applied to them. These operations help us to combine and